All right, so in this video, we're going to be writing linear inequalities when we're given a graph, okay? So we're going to go back and we're going to think about when we were writing equations, all right? And we're going to focus totally on slope-intercept form. We're not going to deal with point-slope form here, okay? When we're given a graph, we should be able to determine the y-intercept. We should be able to determine the slope. So writing the equations will be pretty easy. And then we're going to finalize the inequality by switching the equal sign to whichever inequality symbol we need, okay? So when I'm thinking about writing these inequalities, I'm going to kind of look at these two graphs right here. Remember, we've got either a dashed line or a solid line, okay? If we've got a dashed line, like in number 2 here, our inequality symbol is going to be either less than or greater than, okay? If we've got a solid line like we do in number 1, then we're going to use either less than or equal to or greater than or equal to, okay? So you can tell right away by looking at the line what type of line we have, whether or not the or equal to part of the inequality symbol needs to be present, okay? Second thing we thought about when we were graphing these things was where do we shade? Well, here we have a graph, so we already have the shading, and that shading is going to lead us to a specific kind of inequality symbol, okay? If you look at a line and we consider the shading to be below that line, okay, that's where we're going to use either less than or equal to, and I'll go through an example of that in these following problems. If the shading is considered to be above the line, then we're going to use the greater than or equal to, okay? If you're not sure which it is, remember you can always test a value, like we tested the origin when we were graphing these manually, and you can see which symbol you need to place in, okay? But we're going to talk about the shading in terms of being below the line or above the line for these inequalities, assuming they have two variables, both x and y, okay? All right, so let's look at number 1 here. First thing I want to think about, remember, we're talking slope and y-intercept, so I can look at this graph and determine both of those things, okay? So the easiest one to pick out here is going to be the y-intercept. So what is the y-intercept for this graph? And we can see this graph crosses the y-axis here at -2. So my b value is -2, okay? The slope, remember, I'm going to have to count that. I don't have to use the formula here. So what is the slope? Well, from this y-intercept, I can count. I'm going to go up 1, up 2, up 3, up 4, up 5 before we go over 1 full unit. So the rise here is 5, the run is 1, so my slope is +5. Remember, a line that goes up and to the right has a positive slope, okay? So that's why the slope is +5. So I have everything I need to write an equation, okay? The difference here is I don't need an equation, I need an inequality, okay? So because I've got a slope of 5 and a y-intercept of -2, I'm going to have y is equal to 5x minus 2, all right? This shading is said to be above the line, okay? It's above the line. We've got a solid line, so I'm going to use greater than or equal to, okay? The line is solid. The shading is above the line, so I'm going to use greater than or equal to, okay? So the inequality for number 1 is y is greater than or equal to 5x minus 2, all right? Try number 2 and then come back and check your work. Okay, for number 2, notice here we've got a line here, we've got a dashed line. The shading's going to be below. We'll talk about that a little bit more later, but remember, the first thing we want to do is we want to pick our y-intercept out. So here the y-intercept is at the origin, so b is going to be 0, okay? Slope is negative, okay, because it goes down and to the right, but from this y-intercept we go down 1 and right 1, so the slope is going to be -1, okay? So that would give me an equation of y equals -1x. All right, but again, we're doing inequalities here. I said before the line is dashed, okay? The shading is considered to be below the line, okay? So therefore, I'm going to be using less than as my inequality symbol, okay? So when I write this, I've got my slope, my y-intercept, I've got my inequality symbol. So it's going to be y is less than -1x plus 0, okay? I don't need the 1. Negative there is understood to be -1. I don't need the y-intercept of 0. There's no constant here, so this will be sufficient. All right. Let's take a look at number 3 and 4. Here we're dealing with a vertical line here in number 3 and a horizontal line in number 4. Okay, so think about what those lines, how we represent those with equations, and then change your equal sign to an inequality symbol based on whether the line is solid or dashed and where the shading is. Okay, so give those two a try and then come back and check your work. All right, so for number 3, notice we have a vertical line. Okay, it's important to remember that vertical lines always have the form of x equals some number a, okay? And in this case, the line goes through x equals -2. All right, so here we're going to have a equal to -2, okay? So my equation for this line would be x equals -2, all right? But we've got an inequality because we've got shading here. The line is solid, okay? The shading is to the right of the line, okay? So therefore my symbol, my inequality symbol, is going to be greater than or equal to, okay? So x is going to be greater than or equal to -2, okay? X is greater than or equal to -2. So that represents this graph, okay? Based on the fact that we have a vertical solid line with shading to the right, okay? So to the right of -2, you know, here x is -1, here x is 0. So every number to the right of here, x has a larger coefficient than -2, okay? Along the line, x has a coefficient, or excuse me, x has a value, a coordinate of -2. So that fits as well, okay? Number 4, we have a horizontal line, okay? So y is going to equal this value here. So remember the form for y equals, for a horizontal line is y equals b. In this case, y equals 3. So we would say that the b value or the y-intercept is 3, okay? We have a dashed line. The shading is below the line. So therefore, we're going to be using less than as our inequality symbol, okay? So we've got y equals 3 as the equation. But for the inequality that's represented by this graph, it's going to be y is less than 3, okay? So that's 4 different types of problems you could use to write linear inequalities, okay? So refer back to these as you're working on problems on this topic.